In this video, we're going to explore how Newton's method can be used to solve the x-axis intercepts of a function. Let's get into it. Newton's method is an alternative approach to finding the x-axis intercepts of a function. Typically, it's used for these difficult polynomials that can't be easily solved by using factorization. Newton's method is a numerical approach. This means that it's a process that repeats over and over again to achieve an approximate solution. Here's how it works. Suppose we have the following polynomial and would like to find its x-axis intercepts. Factorizing this kind of polynomial is off the table, but we can use its graph to figure out an approximate solution to where the x-axis intercept might be. We can see that the solution is somewhere between 5 and 6, so let's just choose 5 for now. The guess doesn't need to be super accurate, it just needs to be close enough for this to work. If we were to find the tangent line to f of x at x equals 5, then it would look like this. Notice how the x-intercept of the tangent line is closer to the intercept than our initial guess? That's important, because it's much easier to find the x-intercept of a straight line than it is to find the x-intercept of a polynomial. The equation of this tangent line comes out to be 132 minus 25x, which you can find using the Cas tangent line function. The x-intercept of the tangent line is therefore 132 divided by 25. This solution is going to become the new guess that we then plug back into the Newton's method approach. So we're going to find a new tangent line at this new x-coordinate, and sure enough, the intercept of the new tangent line is going to be closer again to the solution that we're looking for. You can repeat this process over and over again, and you'll get closer and closer to the solution that you're looking for. This is how Newton's method works. Newton's method can be simplified to the following expression. xn is the current guess, and xn plus 1 is the next guess. F of xn is the y value of the current guess, and f dash of xn is the gradient of the function at that current guess. The good news is, these questions are always tech active, so here's a quick method to set this up in the Cas. First, we define the function in the Cas. I'm going to use the polynomial from the previous example, and I'm going to call it a of x. Next, you're going to define the derivative of that function as another variable, which I'm going to call b of x. This is important. Make sure you define the derivative with respect to the previous variable. Don't just type out the same rule. This will become important later. And lastly, you just define the Newton's method function, which I'm going to call c of x. Again, make sure you use a of x and b of x in the definition. Don't just type out those rules. And just like that, you've defined Newton's rule in the Cas. The advantage of doing it this way is that in an exam, all you have to do is update a of x, and all the other functions will update accordingly. Last time we chose x equals 5 as an initial guess, so we're going to plug in x equals 5 into the Newton's method equation. And sure enough, we get x equals 132 divided by 25 as the next guess, which is exactly what we got last time. Plug that new solution back in one more time, and that's going to give us x equals approximately 5.25, which again is what we got last time. We can keep doing this process over and over again until we're satisfied with the accuracy of our answer. And when it comes to Newton's method, it usually doesn't take very many iterations to get a very accurate answer. Let's have a look at an exam question where this was tested. This question came from the 2023 Tech Active exam, and it's telling us to find the next 3 solutions to h of x equals 0 using Newton's method. If you set up Newton's method in the Cas like we did earlier, then all you have to do is change a of x to be the new function h of x. Once you have that, you're just going to sub in our initial solution, which is x equals 0, and keep feeding in the new x values into Newton's method until you fill out the table. That's 2 marks in roughly 15 seconds. And considering the pace is supposed to be 1.5 marks per minute, this is a massive time save. If you found this video helpful and would like to see more, I actually have written versions of these lectures available for free on my website. Just click the link in the description below and it'll send you to my website.